here on how to define, how a syntax of a custom defined function looks. So here we're writing our first custom defined function. So this is def, telling computer that this is a function I'm defining. Then I pass in the name of the function as first func. Then I simply don't pass in any parameter because I don't have any parameter anyway. But what do I want this first function to do? To print, this is my first function. So let's go. So that's it. This is my first function. So that's about as simple as it can get. Define first function. Remember to open your brackets, but you don't have to pass in a parameter if you don't want to. Mark it off with a full colon, then pass in whatever expression you want to pass in. So here I said there's return, right? But I said it was optional. And obviously I don't have a return here. Okay, so now let's see. You can also pass in arguments. The first example I showed, I didn't pass in an argument. But the next example, we'll be passing in an argument. An argument is a value that serves as input into the function. It can be just one or many. So a function, the example below, a function that calculates the mean of a list of numbers. Excuse me, please. Okay, so I'm defining a function that calculates the mean of a list of numbers. So that means the function, I define it as mean. It must accept a list of numbers as input. So now in the indentation or in the function block, now I do some operations here that are very easy to follow along. Here I simply sum the list. Here I get the length of the list. So these are also some inbuilt functions I'm calling on here. I'm calling on sum to sum the list. I'm calling on length to return the length of the list, the number of items in the list. So here I'm computing the mean. So, and remember the mean is the total sum of items in the distribution over the number of items in the distribution. So I find the mean here. So here, I'm also rounding the mean up. So just in case the mean is not a whole number, I want to round it up to the nearest whole number. So here, I print out the mean, rounded value of the mean. So here, I've defined my function. What next? Now let us call out mean function, or let's call our mean function. Okay, so we are calling the mean function. See, mean, I'm calling this function and I want it to return the mean of these lists that I'm passing into you. So let's see. And there it is. The mean of 3, 5, 6, 3, 8 is 5. Okay, so now the example here shows that, okay, you have to pass in one argument here because we define it with just one argument. What if I want to define a function that accepts as many arguments as possible? So let's see it here, arbitrary arguments. And this is the syntax. I simply put an asterisk on the arguments I'm passing in. So let's try this function. In this problem, we're trying to write a function that changes how print works. Yeah, ordinarily we know how print works. But we now want to create our own print function. I'm giving it the name myPrint. and I'm passing in objects. So I don't want it to take just one object. If you remember how the normal print function also works, it doesn't take just one object. It can take multiple objects. So here I'm passing in objects and I'm putting this star or asterisk just before the name of the object. So telling it that these objects can be one and it can be many. So and I'm saying print objects. Now, why I say I'm redefining the function is this. Instead of the normal way a print function works, that it sets this separator argument as a single space, here I'm setting the separator argument as this, something else entirely. The end argument also, typically in the print statement, is new line. New line, remember how to write new line? /n, /n. So instead of the default value of /n, I'm passing in this just to show how it works. Okay, so, and here I'm calling my print. So here I passed in just one object, but I told the computer that this one object can be many. And here I'm passing in two parameters into my print function. So let's see how it works. Okay, so it writes hello. It calls on the separator argument and separates it with this. Then it ends it with this. So I could choose to hello world. It is a bright day, and it's still going to work just fine. So anytime I want to print, I could simply call these my prints. Even down the line, I could just simply call my prints if I want my prints to always print this way. So I have successfully modified how print works, because I will no longer call this print. If I actually want this print name to be used for my function, I can actually copy it, or I can actually name my function this print, and it's going to override the built-in function print with this new defined function. But I don't want that, so I leave it as is. Okay, now, how to use return. So I mentioned earlier that you could actually return a value in your print. What we've been doing so far is we've just been printing out whatever is in our function. But just in case you want to be able to pass the result of your function into another variable, so you have to call on your return keyword. So here, the example here, we're writing a function that takes two lists, names and surnames, and combines each pair of the names together as a name-surname pair. Okay, so as usual, I instantiate it by saying def. I give it a name, and I tell it to take just two arguments. So, and I'm doing some operation here. So I created a list here, combined, an empty list. I loop through each of the names. Initially, I zip. Remember the zip function, how it works. I zip first name and last name so that it can match corresponding first and last names. So I zip, and I loop through it by calling name and surname. So picking name and surname, each round it picks name and surname. It comes here and it does something here, which is concatenating name with space and with surname. After doing that, it appends it to this combine. Remember, when we discussed for and while loops, I said, okay, so no, it was in the class we discussed about data types, lists, when we discussed lists. I said list had some methods. So one of the methods of list is append. It allows you to add a new value into a list. So the empty list we have here, it will get updated as this loop runs. So each time this loop runs, the name and the surname that gets concatenated with a space gets appended or added into this empty list. So, and at the end of it, it comes and returns the combined list here. So let's run it. Here we have created list of names and list of surnames, and we are passing the list of names and list of surnames here into this function we have created with name merge names. So we pass in the names here, we pass in the surnames here, and the result we want it to be stored in this variable name sir, and we print out the variable here. So let's see it. So there it is. Kunle from name gets matched to Ansaidi. So Kunle Ansaidi, and Gobir from name gets matched with Okoli. So here we have Gobir Koli. So now let's do some simple and interesting mathematics. So let's see mathematical function examples. So here we are trying to create a function that squares a number. So you give it a number, think of it as a calculator where you press a number and you press square equals to, and it produces an output for you. So we're trying to write a function that does that. So we define a function with the name SQ. The name can be anything, remember. So what is it returning here? It's returning x squared. In Python, in order to square any number, you do so by calling star star or asterisk asterisk or multiply multiply. It's actually not multiply, let's just say asterisk asterisk. So you call it twice and you pass 2. If I wanted to make it cube, it would be 3, and so on and so forth. So here is just square. So you can experiment on your own with cubing, with raising to the power of 4 and other things. Okay, so here we're printing the output. So let's see. So square of 4 is 16. Let's pass in other values to see how it works. So let's say square of 6. Square of 6 is what? 36. So that is it. I could also optionally pass it to a variable and say square of 12. And here I'm printing my result. Square of 12, 144. Okay. So now, a function, this example here is a function that tells if a number is odd or even. So you want to know if a number is odd or even. So we write a function to do that. We define the function and give it a name, is even. So the function is going to tell us whether true or false if a number is even. So we pass the number as an argument here, x. So now I'm saying I'm defining an output and I'm setting it to false. So I'm assuming, okay, let the output even be false. So in the next line, I have an if statement that checks. So remember, before you can, a good thing about Python is any problem you have to be able to define it. So in order to know if a number is even, from our primary school, we learned that if a number is divisible by 2, then it is an even number. And that's the same thing we're executing here. So the function, the operator I'm using to check here is called a modulo operation. I'm going to add a comment that explains that. Is a modulo operator. So if you remember what a modulo operator is, a modulo operator is used to check for the remainder from dividing a number. So for instance, 5 modulo 5. 5 divides 5 without a remainder. So the remainder is 0. So 5 modulo 5 is 0. 6 modulo 5, on the other hand, is going to be 1. So 12 modulo 5 is going to be what? What's the remainder when you divide 12 by 5? Say again, please.
2.
Fantastic.
2 point something.
So it's actually 2. It's not 2 point anything. It's 2. Because when you divide 12 by 5, you get, it goes 2 times, but there's a remainder. And the remainder is what? 2.
2.
Yeah. So it's 2 without any point. Let me give one other example. So let's say 17 divided by 3. 17 divided by 3. Oh, sorry, 17 modulo 3, rather. 17 modulo 3 is what?
2.
2 as well. Fantastic. So now we're checking that here, x modulo 2. Now, this x is the input you are giving in, right? So whatever number is supplied as the parameter here, try to divide it by 2 and get the remainder. That's what this modulo is doing. I'm talking about just this part I highlighted. So assume it is, say, 17. 17 modulo 2 is what? 1, right? So it's now going to check if this 1 is equal to 0. Is 1 equal to 0? Obviously, no. So if 1 is equal to 0 and if it is false, it cannot come into this block and execute this. It simply stops here and goes to the next line outside the block, outside this if block, because the result here is false. However, let's consider an even number, say 18. 18 modulo 2 is what? 0. So the check is 0 equal to 0. Of course, it is true. It comes into this and sets the output to true. Remember, output has been defaulted to false here. It comes in here and changes it to true because a true condition has allowed it to come into the if block. So, and after executing this, it comes to the return statement and returns the current state of the output. Okay, so let's see it in action. So I'm passing 2 print statements. One is checking for 8, whether 8 is even, and the other is checking whether 13 is even. So let's see the result. So the result is this. This input is 8. Is it even? True. This input is 13. Is it even? False. Now, this is a rather verbose implementation of this problem. There is a more concise form of it. So this is a more concise implementation. Remember, this part of the code simply checks for the remainder here. Now, whatever it gets here, it compares it with 0. And remember, as with any comparison, it returns true or false. So we can simply return the results here, whatever it returns, whether true or false. So that's what I'm passing in. I'm passing the return value as this. So what I'm telling is check the remainder of this operation, compare the remainder to 0. And that is what you should return. So here, the same thing we did up there, we do it here and we get exactly the same result. So going forward, we have recursive functions. So we discussed recursion when we discussed loops, and we executed Fibonacci sequence using a while loop, a for loop rather. So we can do the same thing with a recursive function. Excuse me. Now, what is recursion? A recursive function is a function that calls itself during execution. It calls itself. So think of it, you define a function, and when the function is executing, it calls on itself. It calls on itself again and again until it gets to the tail of the recursive function. So that means your recursive function must have a tail. So let's see an implementation of it here. So here we're defining the function and we're calling it if. So it takes in the number of the number of terms from Fibonacci sequence that you want to execute. So here we say the term is n. Now this happens. It calls this. Okay, excuse me, please. So now into the function block, the first thing it does is this. Okay, I think I should even, let's think through it before we go into how I implemented it. From the class on for loops where we explain recursion. So you have 0 and 1 as the first two terms of the recursive series. And to get the next number, you simply add 0 and 1 and you get 1. So the most recent two numbers are 1 and 1. To get the next one is 1 plus 1 and you get 2. The most recent two numbers are 1 and 2. To get the next number is 1 plus 2 and it gives 3. So the most recent two numbers are 2 and 3. To get the next number, you add the 2 and you get 5, and it goes on and on. So that means we must find a way of defining the first two numbers that start the sequence 0 and 1. So, and that is what happens here. So I set a condition and say, if this n is less than or equal to 1, simply return whatever value of n that it is. So when n is 0, it returns 0. When n is 1, it returns 1. And we have our first two terms, right? So now, but what if this condition is not satisfied? What if n is 2, for instance? So this condition is not satisfied the first time, right? So it comes to the last line, and it comes here. And here you see that I'm calling the same function I'm just defining, or I've just defined rather. But instead, I'm saying, yes, call this function, but don't execute the current one. Execute the one just before the n value that is passed in. So n is 2, n is 3 in this situation, since we want to get 0, 1, and 2. So n is 3, the length of the sequence. So n is 3. Now, the third term is n. Here we now want to get the second term. That's why I'm saying n minus 1. So this is going to return the second term. Right? Is everybody with me?
Yes.
It's really important to understand how
Yes.
the recursion works. So that's why I'm trying to take my time to explain it. Okay, so I have said so far that you define a function, and in this function, you want to return these values, first three, 0, 1, and 1, which are the first three values of a Fibonacci sequence. So this is the first, this is the second, and this is the third. So now I say, if the value passed in here is less than or equal to 1, simply return the value. So when, assuming it is Fibonacci 0, we call. If it gets here, it's going to return 0. If it is Fibonacci 1, we call. If it gets here, it's going to return 1. But here, we call Fibonacci 2. And it checks this condition. 2 does not return true here. It comes here and calls Fibonacci 2 minus 1, which is Fibonacci 1. So when it calls Fibonacci 1, it runs back here and checks, is 1 less than or equal to 1? Of course, it is true. So it returns 1. Right? It returns 1. We have our return value here. So it comes here and executes this 2 minus 2, which is 0, right? So is 1 0? Now, if 0, it comes here. Is 0 less than or equal to 1? Which is true. So it returns 0. So here it returned 1 here, and here it returns 0. Right? 1 plus 0 is 1, and you get your 1 here. And it goes on and on. So here, let's see it in action. In order to see it, because each time you call fib, let me comment this out so we can see. So each time you call fib, so let me assume I'm calling fib 0. Fib 0 returns 0. 0 is the first in Fibonacci, is the first item in this Fibonacci sequence. Fib 1 is the second, right? Fib 2 is also 1. Fib 3 and on. So here we want to print fib 0 to say fib 5. So instead of doing it one after the other, we use a loop. So let's say range. So remember, our range starts from 0 and terminates on. So if you want to stop on fib 5, so there it is, and it goes 1, 2, 3, 4, 5. You can see 5 items from the Fibonacci sequence printed out for us. So you could make it 10 and see it as well. You could make it 20 and see it. Okay, so the same way we used recursion to create Fibonacci sequence, we can use it to execute factorials. If you don't know how factorial works, you can go to Google and type in factorial. It's a way of multiplying recursively. So if you, sorry, is outputting factorial of negative number. I just want factorial. So you do the research. You don't want to waste more time. Let me simply close it. So factorial, if I want factorial of 3, factorial of 3 is going to be 3 times 2 times 1. Factorial of 4, 4 times 3 times 2 times 1, and so on. Now, you can see that this is also a good use of recursion. If you say factorial of 4, so starting from 4, it has to get the value of 3 and multiply it by 4. Then get the value of 2 and multiply it by 4 and 3. Then get the value of 1 and multiply it by 4 and 3 and 2. So we can see that's a good use of recursion. So in this example, or in this implementation, let's see how it works. If we have factorial of 0, factorial of 0 is 0 by rule. Factorial of 0 is 0 because there's actually nothing to multiply it by. But by rule, it is 0. So if you read about factorial online, you'll get that. So here I'm doing the same thing I did in recursion. If x is less than or equal to 1, factorial of 1 is also 1. Factorial of 0 is also 1, as I said. So now I'm checking if x is less than or equal to 1. Just return x. So if x is 0, factorial of 0 is 0. Is 1. Oh, excuse me. I should put 1 here. I should put 1, not x. So factorial of 0, return 1. Factorial of 1, return 1. How about factorial of 2? If it is factorial of 2, when it comes here, 2 is certainly not going to return true here. So it comes to the last return statement here. Says 2, that is our x here, multiplied by factorial of 2 minus 1. So that's factorial of 1. So when it calls this factorial of 1, it comes here and checks. Factorial of 1 is less than, 1 is actually equal to 1. So it returns true here and it comes into this place and returns 1. So they're going to have 2 times 1 here. So if it is 3, it's going to be the same thing. It's going to start from 3 times factorial of 2, right? So factorial of 2 is going to execute similar thing and come and say 2 times factorial of 1. So by the time I'll share this notebook, I'm going to add a further breakdown of this factorial. So now let's see it in action. Here, I've not called the factorial, so let me call factorial of, say, 3. Factorial of 3 is 6. 3 times 2 times 1, 6. Factorial of 4 is 24. Factorial of 5 is 120. Factorial of 6 is 720. Factorial of 7 is, oh, I don't know. And it goes on and on, 50, 40. Okay, so that's it. We have come to the end of today's session. So here I have I've listed out 4 exercises for us to try our hands on. The first one is for you to create a function that converts Naira to dollar at an exchange rate of 360. So you modify this portion of the code and you change its return to return whatever value the exchange rate is. As it is now, it's going to return none. That's it. The second problem, modify the above code to only return a result when the input is positive and integer. Okay, so actually there is a slight mix-up here. I'm supposed to say modify the factorial code, not above code. Factorial code. So only return a result when the input is positive and integer. So here you write a function that only returns the first 3 letters of a name. So a name is passed in as a string and it returns just the first 3 letters. And the last exercise, last question here, the last problem says, write a function that grades students' scores using the scale below. So let me put the scale in a better form. Okay, so that's it. So that returns the grade of a student based on this. So your grader is going to accept a score as input and is going to return the grade of that score. So here I have a code that's going to test it. You can for yourself. You don't have to modify this code. It's going to test if your function